Hi, so now we will continue to the extra activity 3, the mechanism action of different classes of diuretics. Moving to the first one, carbonic anhydrase inhibitors. The location is on the proximal convoluted tubules of the nephrons with the mechanism of actions reducing reabsorption of bicarbonate. Inhibitions of bicarbonate uptake by the proximal tubules will result in the alkalization of the urine. So the next one is the osmotic diuretics, where location is at the proximal convoluted tubules and also the loop of Henle. Its mechanism of action is increased solute concentration within the tubules. It will cause the water retention in the tubules as well as prevent water reabsorption. This will cause reduced plasma volume as well as will decrease the blood pressure. Continue to the third diuretics is the loop diuretics, which the location of action is mainly the ascending limbs of loop of Henle, and its mechanism of action is it will inhibit sodium-potassium 2 chloride co-transporter, prevent the chloride ion reabsorptions, and in long term, this will prevent calcium ion and also magnesium ion reabsorption. So, the main mechanism of action of loop of Henle is actually prevent sodium reabsorption and also to increase the urine flow. So how it acts? By preventing sodium reabsorption, it will alter the concentrations and cause the prevention of water reabsorption, and which means that the sodium ion and also the water will remove more from our body. This will reduce the plasma volume and also decrease the blood pressure. So the next is yes. But just now we said that it increased the water remove, so it will increase the urine flow and also cause the increased excretion of all of these ions and also waters, and increase the renin release due to plasma volume depletion as well. Moving to the next one, thiazide diuretics. Its location is at the early part of distal tubules with the mechanism of actions inhibit sodium chloride co-transporter, which cause the increased sodium chloride excretion. In long term, what it causes is the inhibition secretion of calcium from blood lumens and also promotes secretion of magnesium ion from blood lumen. And the mechanism of actions of thiazide diuretics also increase excretion of ions and water. Ions includes the sodium ion, chloride ions, and potassium ion. So increase the excretions and also increase the urine reabsorption in proximal convoluted tubules. This will increase the plasma uric acid. So the uric acid will cause the formation of crystals in the joint and ultimately cause the disease, which is gout. So moving to the fifth one is the potassium-sparing diuretics. The locations of potassium-sparing diuretics is the end of distal convoluted tubule as well as collecting tubules. So the potassium-sparing diuretics is a big diuretics where the mechanism of action includes decreased sodium reabsorption and also prevent potassium excretion and the aldosterone inhibitors. So mainly the potassium Sparing diuretics can classify into two categories, which is first one is the decrease sodium reabsorption and prevent potassium excretion. This is the first category. And another category is the aldosterone inhibitors. So, under this, we have the examples of amiloride and triamterene. And for aldosterone inhibitors, we have the examples of here, the spironolactone and eplerenone. So the action, let's see. So we have to know the aldosterone inhibitors. So before that, we have to know what is the action of aldosterone itself. So aldosterones will increase the reabsorption of sodium and water, as well as increase excretion of potassium. So when we inhibit the aldosterone actions, so it will cause potassium retentions and also increase excretion of sodium ion, chloride ion, as well as water. So the effect of this action is decreased blood pressure, while if the potassium retains in our plasma, it will cause the side effect, which is hyperkalemia. So that's all for the mechanism of action about the diuretics, the 5 class of diuretics. Thank you.